and welcome to solar system simulation. This is group 3 and this is our MFC project for the calculus. And the two calculus topics we use in our report are differentiation and integration for solving the solar system simulation. So planets orbit, as you actually knew in your physics class from high school, orbits around the sun due to the sun's gravity, as explained by Kepler's law and Newton's first law of motion. So the two calculus topics we use in our report are differentiation and integration. Our project was looking at simulating the solar system, as I stated earlier. And in an example of that, we took actually Python for our main program, and also we took it's some libraries of Python to make that simulation, just to have a little bit of visualization of what the solar system looks like. So this is actually what I said. It is just a simulation, and simulations is a worldwide technique used to describe a certain process. When simulating, you develop a model, which in our case is the solar system for the process that you want to simulate. Then you perform some experiments on the developed model to see the behavior of the process over time. So we'll be actually taking the planets orbiting around the sun, and we'll be taking our starting time, and then we will see what's happening, how they are actually orbiting, and their motion around the sun. So firstly, you actually define the date from which date it will start, and also the duration in this is the duration in days, and also we define the mass of Earth and the mass of moon, the sun. Sorry. So we went ahead and defined our planets, and also we defined the solar system, their methods, what we'll be using, and also so when you have the second law of the second law of Newton, he said that the his first law actually said the force is equal to the gravity and the constant gravity multiplied by the mass of the sun, and multiplied also by the mass of the the sun, multiplied by the mass of a planet orbiting the sun, and all of them divided by the planet's distance from the sun, power 2. Yeah. So when you have that, you can actually have the acceleration, and knowing that you have the acceleration, you will actually be able to have, you know, um, the velocity and the distance. So it is just by integrating the acceleration twice to have the velocity, and once to have the distance. So that's what we have been doing here. You see, we defined some of the method for the solar system, and then after that we define the evolve, which will actually take all that the mathematical calculations in in consideration to have the velocity and the distance, the position, like, if I can say, for the planets regarding the sun. Sorry. So yeah, we also use HTML animation in ePython, and also in ePython to display um, the animation. So yeah, that's what we have been doing. And let's now just went ahead and test you know um, our simulation and see what it looks like for the solar system. And first, you need to install some libraries for Python. So we will install using pip. We install Astro Gala, Astro Query. Yeah, we install that. Mm, it will take some time to connect. Yeah, It's connected now and it's running. So yeah, it's kind of you see installing the packages. Once we have all that done, we just go ahead and run our main program. So we'll be running our program and see what it will give us. It will take time to load. Yeah, so you can see this is the sun, this is the planet Mercury, this is Venus, this is Earth, like this is Mars, and it's kind of just you see orbiting orbital motion around the sun. So yeah, that's what we actually simulated using differentiation and calculation, differentiation and integration calculations using also Python as a technology. So we understand that there are so much parameters that we didn't consider because many things happen in the space, many things also um, has to be considered. But this is what it looks like. As I said, it is just a simulation of what it will look like, what it looks like actually in the real time. So after that, we'll be having also we didn't actually have we didn't add all the planets because so some planets are like so much far from the sun. So even if only you have like a big simulation space you can actually include it, but since it's too small so we can't add and everything. And there are also some parameters of the gravity that we didn't consider, and yeah, we understand, and we like for like simulation is now kind of growing, and also this is a better way of actually visualizing real time things, so that to help people understand what is really happening in the real time of things. Yeah, so and we see also that it's kind of growing and more be like schools are using it to help students to see what it really looks like, what they actually try to learn in theory. And yeah, we are so excited to actually also learn more about the topic, and also we want to expand in the way of also since this pandemic, the COVID-19, visualizing how the spread is also going across the continent and also all over the world. Yeah, thank you very much for watching, and I hope you enjoyed the simulation, and I hope that you actually have a better understanding of what's happening in the space, the sun, the planets, their motions, their yeah orbital motions around the sun. And thank you very much.